Okay, so first of all, there is percent. And this is basically equal to divided by 100, which is basically equal to 1 times 10 to the power of 2. Then there is this symbol, which is per 1,000. And it's also called per mil. And this is equal to 1 times 10 to the power of 3. Then there is ppm, which stands for parts per million. And this is equal to 1 times 10 to the power of 6. So what this means is, if, say, we had 400 parts per million of carbon dioxide, that means for every 1 million particles in the atmosphere, on average, 400 of them will be carbon dioxide. Then there is ppb, which stands for parts per billion, and this is 1 times 10 to the power of 9. Then there is ppk, and that stands for parts per trillion, and that is equal to 1 times 10 to the power of 12. And these units are going from largest to smallest. So, for example, if oxygen is 20% of the Earth's atmosphere, then if I want to find out what this is in per mil, then that is converting between 10 to the power of 2 and 10 to the power of 3, which is a difference of 10 to the power of 1 is equal to 10. So I just have to times this number by 10, which is 200. So there is 200 per mil of oxygen in the atmosphere. And this makes sense because 20 over 100 becomes 1/5, and 200 over 1,000 is also 1/5. Then if I wanted to convert between percent and parts per million, that would be converting between 10 to the power of 2 and 10 to the power of 6, which is a difference of 4. So I am timesing by 10 to the power of 4. So I am adding 4 zeros to this. So I now have 200,000 parts per million. Then if I want to convert between parts per million to parts per billion, that is going from 10 to the power of 6 to 10 to the power of 9, which is a difference of 10 to the power of 3. So I am adding 3 zeros to this number. And that gives me parts per billion. Then if I want to convert from parts per billion to parts per trillion, that is going from 10 to the power of 9 to 10 to the power of 12, which is also a difference of 10 to the power of 3. So I'm adding 3 more zeros to this number. And I have parts per trillion. And obviously this number is getting really long and ridiculous. So in atmospheric chemistry, we usually use the units that are most appropriate, depending on the compound that's being talked about. So for example, carbon dioxide is almost always referred to in parts per million. So if we say there are 400 parts per million of carbon dioxide in the atmosphere, if I wanted to find out what this was in a percent, then I'm going from 10 to the power of 6 to 10 to the power of 2, which is a difference of 4. because I am going from a smaller unit to a larger unit this time, it has to be a negative number because the number is decreasing. So it's 10 to the power of minus 4. Then that is also the same as saying parts per million is percent divided by 10 to the power of 4. It's the same thing. So I need to decrease this number by 4 decimal places. So 1, 2, 3, 4. So I then have CO2 is 0.04% of the Earth's atmosphere. Okay, and that is it.